Thank you for watching Hack the File. This is Michael Lopez, and on today's video, we're going to be going over ethical password cracking. Enjoy. All right, we're back. So, everybody, this is my Linux machine. Okay, so I've got a new setup. This is the first video I'm trying on my new Linux machine. Clipchamp is web-based, so hopefully everything comes out okay. I can't download Clipchamp on this Linux OS, but this is a fully Linux operating system laptop that I'm filming from. And the reason why I made one of these is because I want to start doing password cracking and stuff like that, and that takes a little bit of power, and I can't do it from my virtual machines on my Windows setup. So I had to set up my other laptop as a dedicated Kali Linux OS system. And you know what? Kali Linux, I think, has came a long way from I would even say a year ago. Like a year ago, I could not even plug and play anything. So I plugged and played this new mic I bought, this new camera, and it works. Just plug and play, man. And Kali Linux, last year I tried to do this, and it was terrible. It was not plug and play. I had to download all kinds of stuff, So, I mean, I think it's came a long way. So, anyways, we're gonna have fun on this. Now, the video quality might not be as good, but I've got a great camera and I've got a great mic on it. But like I said, the Clipchamp version I'm using for this is web-based, so it might not be that good, but we're gonna try it out. All right, so here's the book. It's Ethical Hacking by Lady Vital James. Oh no, let's click on it. Okay, this is probably gonna be a quick, 45-minute video. I want to go to the start of this. When we start a new book or a new series, this is going to be a new series. I want to start getting. I want to get some more experience in password cracking, right? And just doing this video and preparing for it, because I really do. These videos are troubleshooting videos, so I usually have not done anything or even looked at the book that much yet, and then we go through it together. But in this case, I had to set up my Linux machine, so I had to do a little bit of prep work for this. And so the prep work I did was basically for just to make sure that I can get everything done that I want to do. And I'm just going to do a basic, I'm going to run a basic Linux or basic John the Ripper hash crack of basically my own system, and then I'm just going to delete, obviously not my hash because I have a long password on this, but I'm going to create, first one, what I want to do is I want to create a new user. So I'm going to show you how to do that with Linux. And then we're going to give them like a easy password that we can use, like John the Ripper, to hash crack it, okay? And there's a little bit of troubleshooting that I already did, but I'll go over it and what I did and what I had to do to adapt it, okay? So first off, this book, I don't want to skip too much stuff because this book is really good, okay? And it's Ethical Hacking, Password Cracking by James Lady Vital. Decode passwords using John the Ripper, Hashcat, and advanced methods. Now in this book, he loves Hashcat for some reason. I mean everybody does, right? I guess. But Hashcat cannot crack Yes Script, and that's what we're using now. We're using Yes Script or something, right? This is the newest versions, and Hashcat, I guess they've got to add something in it or something to update it, but it can only crash. I mean, it can only hack old hashes, right? Now, when I'm saying all this stuff and you don't know what I'm saying, my famous words are what? You say it yourself. Google it, right? Let's do a new one, or co-pilot that. That's my new one. If you don't know what I'm talking about, co-pilot it. Do some research. But um, you know, uh, this book actually goes over what all that means, right? So it's pretty cool. So let's go ahead and go to the next. All right, we always start off with um, about the author. Okay, so about the author, James Lady Vital, Late, I don't know how to pronounce that, but it's all right. Vital is a 20-plus-year-old veteran of the computer security industry. After a self-taught career in IT, see, I like that self-taught. James worked on a computer security incident that changed his career trajectory to security. James consults independently and has worked for Fortune 100 companies in various roles, man, including security architecture, penetration testing, compliance, policies, and much more. James is also an instructor at the SANS Institute, a global provider of information security training and co author of three SANS courses: SEC 467, Social Engineering for Security Professionals, SEC 556, IoT Penetration Testing, and SEC 617, Wireless Penetration Testing and Ethical Hacking. When not actively doing security work, James can often be found tinkering with hardware or spending time with his familia, for his family. All right, so we're going to read a little bit about him, and that's about all we need. So, his credentials and all that, we can kind of skip that, but, seems like he knows his stuff. So, I mean, this is going to have stuff. Now, I don't want to skip certain things here because it's gold, right? When whenever you're, I think that knowledge is power, right? We all know this. We need to understand um, the intricacies of the topic that we're learning. Okay, the more you understand it, the better you will be at research and mastering something, right? I mean, this is just common sense, right? So I don't want to skip anything, so I'm just going to go chapter by chapter, but I'm going to touch on it more of fastly, right? So I'm not going to read it word for word. So what we're going to do is we're going to go through this book, and we're not going to have to do the lab setup because this is an OS, right? I mean, my Kali Linux operating system. So we're just going to um, run them from my box, okay, from my machine. But I do have a VM on here too installed, so if we have to download some VMs, we can. Okay, so let's just skim through all this stuff, and we'll get to the really good stuff. Okay. So in this part, we'll introduce you to the concepts behind password cracking, alternate means to achieve your goals such as OSINT, and how to set up and configure your cracking environment. Okay, password storage, math, probability, and complexity. Okay, so we're not going to do any of this OSINT stuff because this is not going to be an OSINT. We're just going to go straight to the password cracking, right? So, so I'm going to skip it until I see stuff that I think that are very important. So, like, what is password cracking? Okay, we already know what password cracking is, right? But we don't know the different types, right? So you have a dictionary based, you have a combination, you have brute force, hybrid, and partial knowledge, also known as mask attacks. All right, so let's see. All right, so there's dictionary based, combination, brute force, hybrid, partial knowledge. Okay, so and we can go through here. Dictionary based attacks, as you might have guessed on the name, use a list of words or phrases as password candidates. The potential password we will test to see if it is the correct password. Then this list is informally referred to as a dictionary, even though it may or may not contain dictionary words. This word list may not resemble a dictionary at all, much at all. This term is mostly a holdover for earlier times when many passwords were based on dictionary words before password complexity requirements, such as adding uppercase, lowercase, and all that stuff. I mean, numbers and all that stuff. Speaking of complexity requirements, it seems like a traditional dictionary words would not be effective as password candidates during password cracking operation due to complexity now. Okay, so let's look at this. Dictionary-based attacks, as you might have guessed, are based on the name, use a list of words or phrases as password candidates. So basically, you're going to get a list of words. Now, this dictionary-based attacks are good. Let's say we have somebody we want to attack. We do research on them. We find out they got a dog named Betsy. They love their car, and they named their car um, uh, Jerry. Shit, I don't know, and or Maryland or anything, right? So then you want to pop those key. I call them hot words. Pop those hot words in there, and then you can run your diction. You can run a crack on it to see if it hits. Because we all know that when you write a password, people that are not good at passwords or remembering them, they think about the easiest thing to remember. Like, I love my dog, so my dog Rover, Rover 123 or whatever, right? So that's basically what the dictionary list is, right? Okay. Also, a good friendly large word list to start with is the RockU word list. Now, every Kali Linux box, I'm sure you know, if you don't know now you know, has the RockU word list. And what happened was this, it tells you actually right here. This is named after the breach of RockU company in 2009, where over 32 million user credentials were exposed. While available in several places on the internet, a common location to download RockU word list is this. We don't need to because our Kali Linux box has it installed. Basically, there was this company called RockU, and it had 32 million users, right? And they all had names and credentials. And okay, think about that. Think about that really good. So, if you ever needed a list of people that really didn't give a care about their usernames and passwords, and especially in 2009 where cybersecurity wasn't that big, you're going to get a lot of commonly used. That's a great 32 million, really. That's a great user sample of you might hit something, right, if you run that against something. Okay, so but it's 32 million. It's huge, and you can pick how many you want to use or something like that. But we won't even do that. We're not going to use Rocket. We're going to use, I think we're going to use a smaller one, and crack a basic hash. Okay. All right. Combination attacks. Combination attacks take two word lists as input and concatenate, append them together. One password candidate for each list to create the password candidate for testing purposes. For example, one word list might contain the words word 1 and word 2, while the second word list might contain the words word 3 and 4. Right? It's a combination attack. Okay. Brute force attack. Do exactly what their name suggests. Every position in the password candidate is filled with every possible candidate for that position. For example, if a password can only be 8 characters long, a brute force approach might attempt A, and then A, B, and then until the possibilities are exhausted. Now, can you imagine how long that takes? They have a long. That would be great if you had like a 4-letter password, but that's why brute force is not. I don't think it's not good in today's age, since people know not to do easy passwords for the most part. Okay. Hybrid attack. Merge some of the characteristics of a combination attack and brute force attack. Okay. So banana 1, 2, 3. It's a combination. Okay. If you want to pause this and read it, you can. But we're just gonna skim through this, okay? Because, like I said, I want to read the things that are important, right, for us to understand what we're looking at, and then I want to actually crack some stuff. So that's why I'm on this machine now. All right. Okay, no, this is important. How passwords are stored and used. Well, it may seem simple how a password is stored on a system. um, you can have a huge effect on its ability to be recovered via password cracking operation and how long this can take. You don't always need to crack. Okay, so we don't need to read this. This is like um, OSINT. He goes into OSINT, and it's true. Okay, but we're not doing anything OSINT. We're just cracking passwords. Okay, so hashing. The idea behind password hashing is to store the user password so that it cannot be retrieved by anyone. There are several advantages to this approach. For the company that stores this password, this represents a strong level of due diligence and may provide some protection legally. Passwords cannot be reverted to plain text, the original password, from hash values, which means malicious insiders with access to the password storage can retrieve the password. The existence of the standard functions to perform this hashing in many application frameworks means it is easy to implement. Okay, so what a hash is if you don't know what it is, you should look it up, co-pilot it, Google it. I don't care. Do some research on hashing, but that is a very very important part of password cracking. Okay, so what a hash does, I'm going to explain it really quick, is it takes a password. Let's say somebody types in their password, it hashes it, but the hash never changes if it's the same. So let's say if my password is password one, right? It makes a hash of that, and password one hash is the same. It's not going to change. So now if I type in password 2 and it creates a hash and it doesn't match password 1 that's stored as a hash as their password, then obviously, boom, you don't get in, right? It says invalid because it's not the same. Now if I put password 3, it's not the same either, right? Now, if I put password 1, it creates a small hash, it compares it to the hash that's stored, and it's exactly the same, so then boom, I get in. That's an example of hashing. So, and it makes sense because you don't want to really encrypt it to change it, because how are you going to compare it? Okay, so it's like, how are you going to compare it to something that's stored, like a stored hash key, to let you in, right? It makes sense. Okay. Now encryption's changed, right? It encrypts the same word 10,000 different ways, right? Using encryption, so it's encrypted, right? But hashes stay the same. So there. With that being said, there's hash databases for certain like password one. Don't ever use that as a password. That's the easiest one to crack, because that's a hash, and then so that's part of a hash list, and then you can just crack that easily. Okay. All right, encryption. Encryption differs from hashing in that the ciphertext, the product of the encryption algorithm, can be reversed back to its plain text password. To do this, one or more encryption keys must be generated and used for encryption and decryption. Okay, so like I said, encryption uses a encryption algorithm or ciphertext, right? That changes it completely, but then it can uh, put it back to plain text so you can see if that's your encrypt and decrypt of it. Okay. All right, so let's just keep moving. Okay, so why are some passwords easier to crack than others? Okay, there are several reasons for this, but it boils down to one thing: how long it takes for a system to guess a password correctly. If we can create a password that increases the amount of time, then we are creating a password that's more difficult to crack. I mean, that's just common sense. But password length. This is going to give us tips to reduce password lengths. We don't care about that. I'm not assuming, but I don't care if you guys know that or not. Go look that up. What is there's a NIST guidance on what password lengths and everything about passwords on online that you can look up, and it'll give you some password help, right? Complexity. Mine is about 17 or 18 characters long. Ain't nobody ever gonna crack that unless they figure out my own style about it or something, right? But they're not gonna crack that with any cracking tool soon, unless we get that quantum computer stuff or something. Or unless they have like a dictionary word list where they have my whole password in there because they figured it out somehow, right? Then they can crack it. All right, a word on ethical password cracking. Regardless of the approach, the objective of this book is to help you use the tools and techniques you need to recover passwords, whether you're a pen tester, red teamer, or whatever. Okay. Okay, so we just jumped through that chapter. I took out the best things I think that we need to understand. Um, then we need to get to, we're gonna skip all this OSINT stuff. I have an OSINT book that I'm going to start doing, so I'm not gonna cover any other OSINT stuff anywhere else. Because the OSINT book I have is going to cover it all. So that's going to be another series coming here soon. All right, setting up your password cracking environment. So this, I think, wants us to download John the Ripper and stuff. I mean, I already have it on my Kali box, so I don't need to do any of this. Now, here's the thing, though. John the Ripper, the one that's installed on my Kali box, does not crack Yes Script. That's an updated version of Hash. It's more secure. So I had to download Jumbo. So I mean, it tells you that here. So it's telling you to go in there and get John Jumbo version. So you can pause all this stuff if you want, and read it, and then download it yourself. But I'm not, because I already have it, right? So follow these commands. Most of this stuff is deprecated, and you're gonna have to troubleshoot through it so bad. But if you pause and follow this, you should be alright. I already have Jumbo installed. Okay. And like I said, if you want, I'm going through this book. You can pause it and do it on your own. But okay, core functions of John the Ripper. It's a password cracking application. Offers different modes of operation, each designed for specific types of password cracking. The primary mode is as follows: wordless mode, single crack mode, incremental mode. So it's got different modes. And then Hashcat, okay, has become a great alternative for password cracking over the past years, and excels at GPU-based cracking. While cracking via the GPU cannot be accelerated for all hashing algorithms, Hashcat can still introduce significant improvements. So that's another thing. So that's another reason why I have a dedicated operating system and I made it Kali Linux, is because I have a gaming computer that's got really high GPU graphics card, and then it has a really strong CPU, and it has really good hacking capabilities. Okay, so it's got some power. You need power to crack passwords, right? Okay, let's keep going. So we can skip all this. We don't need to set none of this up. Here's that Hashcat. I don't need to. I've got Hashcat already installed. Hashcat binary package is compressed. I already have it, and I can just update it. So this is ZZip. I don't need none of that. I've got a Linux machine. I'm assuming this is on Windows. I don't know. I didn't even know you could download all this stuff for Windows. All right, core functions of Hashcat. It's just a hash. It's literally a hash password cracking tool. That's it. John and hash rules. Okay, now this is very important here. As soon as we get to selecting and using John rules. Okay, so we're gonna do all this on our own. Okay, but here's all the rules. Let's see. We can skip all these rules because we're gonna follow along here in a minute. Collecting and cracking. Okay, Windows. So we might even just skip to the Linux password cracking for now. I'm gonna do another video on this Windows one, okay? Because I don't have a Windows. I don't have a Windows environment yet. Yeah, I mean I do, but I don't know how to use it yet. So I just put a VM in, and I created a Windows VM. But let's work on this one first, okay? Before we get to that, there's a section in here where we want to read about what we're looking at. And okay, so this is a good one too. Unfortunately, a problem with both of these hashes is a lack of salt, or an additional bit of random data that's included in each hash calculation. The value of a salt is that it can thwart rainbow table attacks. Okay, now if you don't know what that is, look it up. But I'm going to tell you what a rainbow table attack is. It's basically what I told you about the hashes. It's a rainbow table. It's a table of all the common hashes: password one, love one, evil one, happy one, or whatever. People, the basic uh, passwords that people use. They have hashes of it. They put it in a rainbow table. Okay. You can use those tables, and you can look up rainbow tables online, and you can use them to crack passwords and hashes. Okay, and keep going on here. A client credentials request, server verification, credentials, server verification, Kuberos. Okay, developed by MIT, Kuberos is named after the mythological guardian of the underworld. While used in many networks, we are interested in its use of Windows Active Directory domains. Now we're going to skip this because we're not going to do Windows yet. I might come back to that. Cracking Windows hashes. So we're not going to look at the Windows. Let's go to the next one. Now this is actually cool. We're going to go back to this, but I'm going to run this on my VM on my Windows machine, and we're going to crack some stuff on the VM because I'm sure if we do some basic stuff, it'll be easy. Okay, so this is the chapter we're going to start at. Linux password cracking. For many users, the Unix and Linux operating system have been the backbone of the infrastructure of many companies, as well as the internet as a whole. Unix and Linux are sometimes referred to interchangeably due to the similarities between the operating systems. However, at their core, Unix is an older OS, has typically been proprietary licensed solution, while Linux evolved as a free and open source OS. This does not mean that there are no versions of Linux that you pay for. Rather these are often for support and maintenance purposes. As such, while this chapter will typically refer to Linux, most of this guidance can be used as Unix as well. In this chapter, we're going to cover the following main topics: collecting Linux password hashes, formatting, converting hashes into their expected formats, cracking hashes. Okay, and note, depending on your objective and reason for password cracking, okay, we don't need that, and we don't need that. Okay, collecting Linux password hashes. To obtain the password hash for Linux, we will need to be able to run the commands on the target Linux device. This means to obtain the ability to run commands on the device are outside the scope of this book and can be more broadly covered in other books focused on penetration testing techniques. So it's not going to tell us how we got it, which that's my role in my other videos, but for now we're just going to practice the cracking, is what it's saying. These techniques can include, but not limited to, exploiting blah blah blah. Thoroughly covered in other resources. For now, we will assume you have access to the user account on your machine and you show an output presented in the terminal. Linux password hashes are commonly represented in a file typically located at the etc shadow. Remember this. Now, if you're getting into cybersecurity, you're getting into hacking or penetration testing, you need to remember stuff like this. So we need to know that where like a Linux or Ubuntu or any kind of Linux OS system, they store their password hashes in the etc shadow file. Okay. All right. Allow access to this file is restricted to the root user or someone who can run commands as root. Now, this is the other part of the hacking. Users via utilities such as sudo. The output of an attempt to access the etc shadow file with the normal user privileges is shown like this. It's going to say access denied. So we can even run that. So cat etc shadow. So let's look here. I'm going to open up a terminal here, and it looks zoomed in here because I was running a VM and I had to zoom it in. So we're going to cat etc. Oh, I got to put the cat etc shadow, and I think it's capital shadow. Permission denied, right? Because I'm not signed in. But let's go ahead and sudo kung fu sudo that sucker, boom. Okay, now I'm gonna pop in my right. All right. So now I'm the only user in here, so it's only gonna show me and my hash. But good luck on trying to crack that hash. Anyways, so we'll go ahead and add some users. I'm gonna add a user here, okay? So, all right, so let's go ahead and create a new user here, and I'm gonna call it Betsy. So let's open a terminal here, and I'm gonna create a new user. So I'm gonna sudo, I think it's user add, yeah, -m, and let's call Betsy. Let's just say Betsy, okay? Now it's gonna ask for my password, of course, because I'm the administrator. Okay, so now let's add sudo ID Betsy. Alright, so she's in there. The reason why I'm using Betsy is because I already used John before and I deleted him. But in John Jumbo, or when I used the hash cracking tool, John the Ripper, it stores all previously cracked hashes. So if I put John and I use the same hash, it's gonna pop it out instantly, and I don't want it to do that. I want to show you guys how it actually runs it and tries to crack it, okay, against a file. So let's go ahead and set. Now she's in there. Let's go ahead and set up her password. So I'm gonna go sudo password Betsy. See, I already had John in there, and let's give her one that's easy to crack, right? So I'm just gonna use love123. Okay, so LOVE123, LOVE123, right? And that's just something easy, right? So now we can go in and sudo cat etc password, and that's where we store our password hashes, right? So that's where we're looking. Okay, now let's look at Betsy's, okay? And we're gonna look at it in its entirety. So let's take a look at this bad boy, and let's go ahead and see what these parts are. Right? Oh, where's my book? All right, so that's why I like this book. It's going to tell us what we're looking at, right? So I'm going to copy and paste this actually. So let's copy this, and I'm going to open up a new document text file, and I'm going to paste it in here. All right, let's bring this over here. Now that's Betsy's hash, right? That was pulled from the etc file. Okay, we're gonna look at each piece of these, okay? For here in a second. So, all right. let's unpack the contents of this file. Okay. Each line represents a different user account. There are 8 pieces of information in each line, and they are separated by colon character. These 8 pieces of the information are as follows. The username is the first field on the left of the line, up to its first colon in the username. This is the name the user will utilize to log into the machine. So let's go back to our how do I get to my Windows? Okay, here we go. Okay, so let's look at this. So that's Betsy. That's the user, right? Before the first colon. Okay, fine. Okay, let's do the next one. Password hash. The second field is the password hash. You will notice that on all the accounts except for James' SOV account, we're not worried about this because we didn't look at his. The password hash is represented as a star or a exclamation character. This means that these users have no password set. This also means that their users cannot typically log in with a password-based login. You will notice, however, that the James user has partially redacted password. Yes, that's interesting to know. Okay, so let's go back here. And she doesn't have that because she has a set password. Okay. Last password change. The third field indicates the last day the password was changed. This doesn't note the date itself, but rather the number of days. January something, also known as Unix epoch. This date was selected by Unix engineers, January 1st, 1970. In the 1970s, to represent when time as a Unix system knows it began. Linux maintains the same format. So let's look and see what that is. So is that, what am I looking at? Where did he say that was? On the end? The next field? This field? That's weird. Okay, hold on. Minimum password age, the fourth field. So it's looking at these. Man, you can't even see those. I don't know what this is looking at. But let's dig into the password hash field 2. So what field was it looking at? I don't know what the hell. We didn't have none of that. Okay, so let's dig into the password hash field in more detail since a lot is going on here. This field follows the following format: ID salt hash. ID salt hash, huh? I think all this stuff was the date. Okay, 3 pieces of information are in this one field. The first piece, the ID, specifies the ID of hashing algorithm being used. Linux and Unix support multiple types of algorithms for password hashing, and you can have different passwords for different users with different hashing algorithms being used in the same etc shadow file. The common hashing algorithm Linux are followed. $1 means MD5. $2 means blowfish. These are several variations. Blowfish so may represent by 2A, 2B, or so on. $5 is SHA-256. $6 SHA-256. The second portion is the salt. Now let's look at R's and see what kind it is. We have $Y, these two here, right? That means it's none of those, right? That's because that's yes script. That's something new, which they use now because the other stuff is basically used in older systems. But it doesn't mean they don't use them. But that's very important. So when you're looking at a hash, that's very important. You're gonna need to look at what's between these $signs here on this first part of the hash. And if it's got a 6, you know it's SHA-256. If it's got a 1B, 2B, or whatever, then you know it's those other ones, right? But this one has a Y, so it's yes script. It's not in this book yet because this book is kind of old, probably. The second portion of the field is the salt. The salt is a bit of random data that's added to the calculation of the password hash. This means that the salted hash will have a different hash output than an unsalted hash, which has dramatic security benefits. A traditional hashing algorithm will produce the same hash text whether it is presented with the same input. For example, if I hash the phrase password with MD5, the hash output will be this. If I hash the phrase password with an MD5 on your computer or mine or any other computer out there on the internet, this will be the hash output. In the world of password cracking, this consistency causes two problems. If I review the etc shadow file and see multiple password hashes that are identical, this means that the passwords are identical as well. Cracking or obtaining one password will yield the same password for the accounts in the identical hash. An attacker could choose to pre-calculate the MD5 hashes for given word lists or password candidates. This would greatly reduce the time for cracking. We'll just use rainbow tables. To mitigate these issues, we can spice our password hashes up by adding the salt, a randomly selected data value, and store it alongside the password hash. This salt is not a secret. If you have access to the shadow file, you can view it, but it mitigates the attack scenario mentioned previously. The third portion is the password hash itself. So let's look and see what the salt hash was. So is this the salt hash? The J9T? Probably. And then here's your hash itself. Right there. And then this is, let's see what else this is. Okay, looking at figure 6.2, you will note that, oh yeah, we don't care about that. Okay. So, what are the last parts? Oh, what is it? We got a picture here? Okay, so it's using a test add user, and it's going to set up, and it's going to have us crack it. So, oh, I'll skip the damn file. Okay, so the hash itself. When a user attempts to access the system, this hash is recalculated and compared against the password hash using the salt and the algorithm specified. If the hash matches, the authentication is successful. If not, it's rejected. Not all hashing algorithms in Linux and Unix are created equally. Okay. Looking at figure 2. Okay, so now we kind of know what the hash, what we're looking at, right? We know it's not one of these ones, but we know what to identify. So if we can set up a hash with MD5, but we're not. Okay, so now this is going into cracking it, but we're gonna crack ours ourselves. Okay, so we have to unshadow this, formatting converting hashes into their respective formats. The amount of formatting you need to do with the password and the shadow files will depend on the tool you use for password cracking. If you use John, which we are, you can use the unshadow utility to combine the password hash back to its etc password file as it was originally used. The reason for this is the etc password file can contain possible password candidates that John will try if he's aware of them. These are some of the candidates that will attempt in John's single crack mode. Unshadow etc password shadow combined text. So he's running unshadow and he's pumping it out of the etc to combine text. Now we're gonna do something like that, okay? That's the first step. So let's do that. So my neck. So we're gonna do it's the same window. Alright, so what we're gonna do is open the terminal here, and I'm going to make sure Betsy's still there. So ID Betsy, she's still there. Next, I'm gonna make a directory for her her hashes, right? So I'm gonna make directory mkdir, and we're gonna do let me just call it Betsy Betsy demo, and it should make it on the desktop, right? And I'm gonna drag it over here, and then let's actually go into cd Betsy demo. Okay. Now, if you look at our directory, we're in Betsy demo. Okay. Now we want to copy that drive. Now I'm going to take Betsy demo and I'm going to put it over here on this screen so you can see that it created it. So I drug it from my screen 1 to screen 2. So there's a directory we created. Now we're in the directory. So now I want to go. I want to take that. Copy the etc password file, right? But I want to run something on it. So I'm going to go sudo cp, and I don't want to run that one yet. Well, I guess sudo copy, cp is copy. We're going to copy that etc. Want to do, yeah, password. File. Okay. It's asking for my credentials again. Missing distinctive file operand after etc password. Oh, I didn't put it. Yeah, I forgot to put that little operand on there. That. Okay. And let's do the etc shadow file too. All right. Now we can even look and see if we've created those. So now I can even ls this to see if they're in there. And there they are. Created them. Okay. Or I copied them from etc to that directory. And that's what that dot means. The dash dot is saying put it here. I'm pretty sure that's what that means. All right, so now what we want to do is we want to unshadow let's see. We want to unshadow that password file that we copied, right? So the password file, we want to unshadow it because that's what it wanted us to do in the book, right? So we're gonna sudo unshadow. Remember, this is the first step we got to do. That's a John the Ripper command. Password shadow, and we're gonna pipe it to let's do Betsy hashes dot text. Okay, and if we ls that, we're gonna see that there's a Betsy hashes dot text in there now. And if I open that, it'll have the unshadowed password in it, right? Passwords. So let's open it. Cat Betsy hashes dot text. Okay, there you go. So now it has all the Okay. So now what? We'll see the yes script, right? That yes script line. Let's see if it's yes script. Well, it is yes script. All right, let's just see if we can run it now. If we can run the, well, let's go to the book and see what the book says. I'm just getting used to using this dang machine, so you know you gotta let me get a feel for it. Where's my book at? It's a lot different. Okay, here's my book. Alright, so note that if you run the preceding command and the system returns an error that it cannot find the file, run the command from the directory where it's located. So, unshadow, you can substitute the preceding values. Okay, so we already got this. Okay, so now the combined file, anything you like, a sample of the unshadow command. Right, so this is a sample of the unshadow command. We got something like that. In the preceding code, you can see the output of the unshadow command shows the elements of the etc password file, such as the geckos field and the hashes from the etc shadow file. If you plan to use hashcat, which we're not, you need to use an etc password file. Instead, you can copy the etc shadows file context and use it for hacking. You can readily copy and paste a line from the etc shadow file to a separate file for cracking. So we could do that, or we could just do a command and like, cut concatenated out, right? But you could just copy and paste just the hash part, since we know what part is just the hash now. Okay, we're not going to use hashcat. We're going to use, because hashcat cannot crack yes script yet. So we're going to use John the Ripper. So we're good on that. So let's just use John the Ripper and let's crack this with John the Ripper, okay? Dang it. I'm telling you, these windows are gonna kill me. Alright, so let's go down and see. Okay. Okay. So we just want to grep Betsy out, okay? So we don't want any other hashes in there. Like, I don't want to crack mine. It'll never crack it. So I want to just crack Betsy's because hers is easy, right? So I'm gonna grep hers, all her names out, and then put it to a Betsy only file from the unshadowed Betsy text hashes text, right? So I'm gonna grep first. I'm gonna grep. Now, if you don't know what grep is, like I said, you need to look that up. But it's basically gonna go through the text file that I assigned it or whatever, and only grab Betsy's name. Okay. So I'm gonna go here. I'm gonna do this little up caret. If I can remember where the heck that is. There's my up caret right there. Boom. And then I'm gonna go Betsy. Okay. Now this is a new one, right? So Betsy. Because I put that colon there because that's the username, right? Okay. And we want to take it from Betsy. Hashes was the file, right? .text. And we want to just pipe that to a new file called Betsy only .text, right? Oh, we're, damn it, we're not in the same file. We're on that file. Okay. Ugh. What did I do? So we don't want to do that there. We want to do it. I want to do it in the demo. Okay, so now we're in the demo. And now I want to grep, so grep. And then you gotta do this little caret, Betsy, and then you're gonna do the colon because that's what it shows in there. And then we're doing those bad boys, and it's not John, it's Betsy. Betsy hashes dot text. Now, if you can't follow along, but just keep paying attention. This is a little bit more advanced. It's not a really beginner. There's a lot of concepts in here you'd never heard of, like grep, or even what we're doing. But piping, using the arrows and the up carets and the right carets and stuff. But just follow along as best as you can. Do your own research. But this is basically for a little bit more intermediate users. So now I'm taking that and I'm going to call it Betsy only .text. Okay, now I'm going to ls this and see if it's in there, and it is. So now I have Betsy hashes.text, Betsy only. So basically, let's break this down. I'm going to show you what my. So we copied the password file and the shadow file, and we unshadowed it with John the Ripper. Okay. And what that did was it's going to allow us to do a hash crack on it. Okay. So, but now I took those unshadowed, files and all the unshadowed from our password hashes, and I created Betsy only. So I grepped and just went through the codes, and like, let's say I have 100 users, and I only want to try like 3 of them. I can grep them out and put them in their own file, that's already unshadowed, and then try to hack them. That's it. So it's pretty cool. Okay, so now we want to open up that file. So I'm gonna cat, right? Cat is open. Concatenate cat Betsy only. I want to see if it put her hash in there. And there it is, and that's Betsy's only hash. So mine's not in there, Betsy's only in there. So Betsy, here's her username and the colon that I grepped out. Did it look for her when it was grepping, and then it took her whole hash. Okay. Now this is the yes script, and I think this is the salt. Then this is the hash, and then this is like a time or whatever, and this is the directory where it's at. I don't know. Anyway, so. Now let's see if we can crack it. So all we're gonna do is run John. Okay, so John, that's it. That's your John. That's your John command, John the Ripper. So you're gonna press John, and then now I'm gonna Betsy only .text, right? Let's see what happens. No password. Oh, I gotta load those passwords. So I gotta combine them, right? Is that what it said I had to do? Let's go back and go look. All right. Oh. Man, I have to use the list. I'm sorry. All right, so what word list are we going to use? So we can use rock you. Is that what it said to use? And I think it should be able to crack it fast. So let's just use rock you. Okay, so let's find out where rock you is though. So I'm going to open up. I forgot to put the damn list. So I'm going to open up home, and I'm going to move it over here so we can see, right? So your home, you can't see my screen because it's on my home screen. But if you click on this home on your, on your screen, and you go to, there's John. Never deleted him or what? Users. I don't remember where the hell that's at. where's my user at? Okay, so it's not in that home. It's in your right here. Now it's gonna need my password. Okay, so now we'll go to users in here. Okay, so it's gonna be in your hard disk in your Linux, not in your home. So I'm gonna go to users, and then it should be share somewhere. Public. Huh. Default users. I'm gonna share it here. Man. Not seeing any users share. Yeah, let's just go ahead and run this and see if it works. I don't know where the hell why that's not. Oh, it's usually in share word list. So users share word list. So that's the common directory in here. All right. So I have a bash script that basically runs John Jumbo for me, and all I got to do is give it this path. So let's look at it. So let's open this, and so it's a bin bash John the Ripper Jumbo. It's gonna run it from. I had to install it in my home directory so it doesn't mess up my whole damn OS system. So it's gonna say Ripple Jumbo and hash mode only, or only in hash mode. So it's gonna check for John if it exists. It's gonna ask me on an output, what's the full path of the hash file. So I'm gonna give it that hash file. I'm gonna get the full path from that directory. Then it's gonna run it and it's gonna try to crack it for me, okay? And it's gonna auto detect, which this is set up to auto detect for yes script. Okay, this took a while to set up, but I made it easy for myself. Okay, so now I have all this stuff is set up. So now I'm gonna go into here and I'm going to get the complete directory. So I'm gonna copy this and I'm going to remember that it's the Betsy only.txt, okay? And that's what I want to run. So I'm going to open terminal here on my desktop, since this is where this is, and I'm going to run. So I'm going to press .that run John Jumbo, johnjumbo.sh, right? Okay, now it's saying, okay, just like we looked at in the bash file, what it said it was going to do. It says give me the full directory path. So I'm going to write this, and then I'm going to do another there, and I'm going to put Betsy only.txt. Okay. Now what it's doing is it's trying to crack this, and it's using it's trying to crack it with its own internal list. Man, that was cracked super fast. So that's how fast this sucker can crack when you have an easy ass password. So basically it cracked it. And if you look at this, it says Betsy Love 123. So that's the hash that it got. Betsy Love 123. And it cracked it. They cracked that hash so super fast because it probably ran it through rainbow tape. Listen what it did. Okay, so open this all the way. So, okay, using default input, loaded one password because it was only trying to crack hers. Algorithm unknown, decrypt, emit. So it's trying to run it against all these, and then it found Ghost yes script. Or no, it probably found this one. script or yes script or this one. It doesn't matter. That's the newer ones, right? Because it used to stop here at 6. Is 10 for all loaded. So it's probably yes script for all loaded hashes. So it detected the algorithm as yes script. Algorithm specific. Okay, so 1 is all loaded hashes. Will run 8 OMP threads. Password longer than 24. It's telling you what's gonna happen if it's too long. Control, but it was super short. Okay, so Control C to abort or send to John process status warning. Only 92 candidates buffed for this current salt. Okay, almost done. Process remaining buff time, if any. It literally took not even 5 seconds. Done 1/3. Jesus, Betsy. Proceeding with word list. So it used password.list. Oh no, because that's the password list we had. John run password. I don't know. Love. That's it. It cracked it. Boom. Love 123, and then it gives you it's done. That's it. Cracked password. Betsy. Love 123. I mean, that was fast. Okay, so that's the video. I'm gonna be running this password cracking. We're gonna get more difficult on this, but basically, the more we do this, the more we're going to get used to it. And now this here is a bash that I had ChatGPT write me. Right, I wrote out the parameters of what I wanted it to do, and I just said, "Hey, write me a bash." You will input this if you don't want to run this. You will input commands in John. So if I go here, I type John help. Okay, there's your John help list. You don't need anything else. You don't need ChatGPT or nothing, right? And you can go in here and say, okay, single crack mode. And you can look at all these. I used word lists. So, I mean, there's all these commands that you can go through and run it yourself. And once you do an unshadow password and file, right? The grep is something that I did because I just wanted to grep out the easiest hashes. So we're gonna do more of this. We're gonna practice and practice and practice. But that first one, because since John Jumbo, it's the old way. John does not have the command. I mean, it probably does, but it's. I think this John right here is deprecated, right? I mean, it doesn't, and then unless they start adding that it can crack yes script, I couldn't do it that way. So I had to I had to download John Jumbo and then create my own bash script. So I don't know. All right, I hope you guys liked that video, and I hope you learned something. I know I did. It's always fun. Oh, actually, I want to go in here and delete this. So I'm going to open terminal, and I'm going to remove -R Betsy. Oh wait, ID Betsy. Like that? I don't know if that's the right command. Okay, hold on. I think it's sudo. How the hell do I remove? Oh, delete user. Oh, okay, I forgot. Okay, so it's user delete. -R. Betsy. I don't even want to look this up. Ooh, man, Linux, these windows, trying to open up these windows. Okay, come on. I just want to delete this guy. Okay, I think John was still in there too. Sudo user delete -r. I just did. Betsy. Oh, she's gone. Okay. Let's see if she's there. Okay. Now I want to do John again. I don't think I deleted him. John? Hmm. Alright, so I don't see anybody in there, so that's good, but his folder was in there. Maybe I can delete, remove directory. I don't know. Anyways, that's it. So I got those removed. And we'll see you on the next video. Have fun.